Cool. All right, let's get started. So first and foremost to this presentation is I'm not a financial advisor and this presentation or what I say is not financial advice. This is something you'll see quite often in anything you watch regarding crypto. It isn't intended to give any financial advice. It's just an information session. But buy Bitcoin. Okay, so let's break down like what a blockchain is. So I'm assuming no knowledge at the moment. So some of you probably know some stuff and some don't. So it's going to spread between, learning something and stuff you already know. But fundamentally, a blockchain is it's a digital ledger of transactions that's distributed across an entire network of computers. Each block in the chain contains a number of transactions, and every time a new transaction occurs, a block is added to the chain. And a record of that transaction is added to every single participating node in the chain. So what it provides is a decentralized way of storing information, and that's as opposed to a centralized way. So when we talk about centralized ways, we're talking about essentially clearinghouses, banks, insurance companies, where they'll store their version of the data in their database, and that data can be altered and it can be deleted and it can be modified. It's not to say that that happens, but it is a fact that that information is modifiable and essentially closed, so nobody has any visibility of what's really going on. So ledgers really aim to provide an open and public view of what's actually happening. What are the problems we're trying to solve here? So really, at the base of it is the blockchain is trying to provide certainty of transactions between two trustless parties on a distributed network with certainty that the transaction is final, complete and consistent. So it's a way of saying, well, if we've got this decentralized ledger of people we don't trust and nodes we don't know who's running them or how to validate them, how do we actually provide certainty that something is actually going to happen and a transaction is going to occur? And when we get into cryptocurrencies, that someone did send me those coins and I do have them and no one can take them away from me. So it's a huge problem to solve, but that's what the blockchain technology is aiming to solve. So they're seeking to achieve decentralization, so no central authority, a trustless network where you don't need to trust the nodes, but you can trust them because it's in the essentially the cryptography and the mechanisms that you can trust it. They aim to prevent double spend. So this is a big mathematical problem for years, where how do you move a currency to a computer but also ensure that that currency is never spent twice? So that was something that Satoshi Nakamoto solved when he created Bitcoin. You need it to be fraud resistant, so people shouldn't be able to change it. It needs to be immutable. That means it can't be modified, as in those transactions cannot be changed, disputed between multiple parties. And also it needs to seek openness. So the big thing about blockchain is the openness of it. There's no barrier of entry. You don't have to be a millionaire in the game or a bank to participate, and you can't be told you can't participate, you can't be blocked. That's why it's very open. What are some of the things that blockchain can do? They provide an openness, a democratic system that does not exclude or unfairly limit its use. So, it doesn't seem a lot to us, that type of thing. Like we can go to the bank and get a bank account and we can put money in that bank account. But, in countries like Africa, but even in America, banks refuse to give bank accounts to people. So they have to be paid in cash because no bank wants to deal with them. They don't have a credit rating. Blockchain doesn't care. You can start transacting on there regardless. There's no seeking of permission. You can perform transactions. You can manage contracts between two parties. You can store data on it. You can run software and programs that are immutable. So you can actually put a program on there, which is called a smart contract. And that's immutable, which means once the program's on there, you can use it because it cannot be changed. And that means it's auditable and everyone can see it. Replaces the need for centralized authorities. It provides a supply chain transparency. That's more of a solution. It reduces fraud and counterfeiting. It can even perform government operations. And some examples I'll show later, they're already doing that with Cardano in Africa with student identity and stuff like that. It can act as an intermediary or an escrow between two parties who don't trust each other. And it can be used with protecting intellectual properties, like, we'll get into that, which is non-fungible tokens, NFTs. You could use it for voting and many other things. So it really is sky's the limit. Some of these blockchains are Turing complete, which is essentially a computer, and whatever you can program on it, it can do. Why is it important? And this is where I got into earlier. So people in many countries, they don't have access to banking, lending, or insurance. Blockchain is non-discriminatory. There's cases in some areas of the world where civil wars or corrupt governments, they take people's land, they destroy the records, and what you thought was your property now is not your property. But storing that information on a blockchain, a government who takes control of another, or an uprising that takes control of the government, they can never destroy those records if they're in a distributed network across the world, stored in immutable data. There's always a proof then that you own that land. Banks and, I'm not going to get too, anarchist, but, the reality is that banks and governments can decide to take money out of people's bank accounts. It happened in Cyprus, where the country was going pretty much belly up with a huge debt. And overnight, they decided that they'd take 10% from everyone's bank account, and there was nothing anyone could do about it because the banks agreed with the government and they took that money. So if your crypto is stored in your wallet, it's yours. Nothing can happen with it, and no one can take it. One of the examples is El Salvador has made it legal tender now because they sort of see that their currency is being manipulated a lot, and that they're moving to Bitcoin essentially. It's a bit of an experiment. We'll see how it goes. It also it also can protect against hyperinflation. This is where countries essentially print their own currency, thinking they'll dig themselves out of a hole, but essentially inflate things to where you see, after World War II, people in a line with a wheelbarrow full of money to buy a loaf of bread. That's hyperinflation. It's occurred in 55 countries over the last 100 years, so it's not a theoretical thing. It's an actual event, and sort of with limited amount of currency that cannot be reproduced, like Bitcoin, that protects against the ability to just print more money. It allows you to send value to anywhere in the world in seconds. So instead of having to use a centralized trading house or an exchange, you'd be able to just send it between two parties without any intervention of a third centralized body. And I'll touch on it later, but you can actually, and there are already examples of, you can get an insurance policy on a blockchain. And if the conditions are met, you are paid out. There's no middle person to decide, oh, wait, I disagree now. And you're not going to pay. You might just want to hit mute there, Saber. If
doing what? And so you're not doing what?
Oh, 1 sec. There we go. And this is just another point is banks on average leverage what you put in. So if you put $100 into the bank, they actually loan out $1,000. So essentially your money is actually not in the bank. When you have a crypto coin, it's actually yours and it can't be leveraged and it's yours to own. So that's just a bit of an intro there. I might just pause if there's any questions or anything at this stage. I can't see any hands up. I'll continue on, or unless anyone wants to ask any questions so far. No. All right, I'll move on. So I'm going to get a little nerdy here because I guess the fundamentals of blockchain is to understand two principles around cryptography. And that's essentially hashing and the cryptography itself. I'm not going to spend too much time on it, but it's just an intro. So really what cryptography is the practice of securing communications. Put simply, it's taking a plain text and converting it to unintelligible text to send to someone, and no one can understand what that is. And anyone can see it, but they don't know what it means until the other person can decrypt that And I'll go into how that happens. And there's another thing called hashing. So hashing is essentially a type of fingerprint. It's a process of transforming any given key or string of characters into another value. This is represented by a short fixed length value that represents it. So it's essentially taking, whether it's a 10 terabyte file or a 10 megabyte file, when you hash it, you get a simple fingerprint, and that is actually a proof of that file is, if any modification happens to that file, that hash will change. And I'll show you an example coming up. So let's dive into cryptography. So really, in a nutshell, cryptography usually works with a public-private key pair. So everything we do on the internet today through the browser is using this type of methodology where you generate a private key and a public key. That private key is obviously kept private and is not disclosed to anybody. It's the keys to your kingdom, but you give out the public key to everybody. They can then essentially over here. So if I'm Alice, I create a large random number, and this is all a public to private key is. It's a large random number. And from that large random number, you then generate a public key. That public key is the key pair. So when we get up here, if Alice and Bob want to communicate, what Alice will do, she'll take Bob's public key and her private key, she'll combine them to basically create Alice and Bob's shared key. She can then use that key to encrypt anything she sends to Bob. And Bob is able to then use Alice's public key and his private key to actually combine them to get the exact same key that they're sharing to decrypt that. So it's a bit of mathematical wizardry, but by just using those two key pairs, they're able to communicate without actually anybody in between seeing what's going on. I'll go into hashing now. So hashing allows you to basically take any large size or any size file or information and hash it into a fixed length, which is generally 256 bytes. It's a one-way operation, and that's important to know. So when you hash something, you'll get a fingerprint, but from that fingerprint, you can never actually go back to generate what the original content was. So that's a way of essentially proving that it's used a lot in IT around saying, here's the hash of this file. So if someone downloads a file, they can then hash that file and compare it to the hash that's been publicized to say, yep, that's exactly the same file that company is giving me, and no one in between has altered that file. So if I took a file that had hello world in it, and then I hash it, I get a hash key. So this is just an example using a SHA-256 hash. So as you can see, I get that number at the bottom. That's the hash, the fingerprint essentially. And it's not possible to take that hash to get back to hello world. It's because it's scrambled enough and reduced enough that it is just a fingerprint and not something that can reproduce the hello world file. Here's another example. So if I took the hello world file now and I put an exclamation mark on the end of it and hash them together, it doesn't vary slightly, it varies largely. Those two hashes there are totally different. So they bear no resemblance of what the contents of that file is. And that's, once again, important in this whole blockchain thing. So if I take this other example here, this is a fairly large image, to stick with the theme of our industry, it's a key crane. I took that photo and I changed 1 pixel on the very top of that crane. And then I hashed those two files together. And as you can see, once again, they get a totally different fingerprint. So that ensures the integrity of information. It says that if someone presented you with the file and says, hey, this is what James gave me, but James gave you the hash, you'd say, well, that's not the file, that's not the original file, you've modified it. I'm going to rush through this one, but it is, there's an article reference down the bottom there. But the cryptography, it's called ECC cryptography, which is the elliptical curve. This is everything we use today. It's everything we do with customs. It's every browser you use when you use HTTPS uses ECC cryptography. The interesting parts of this is it's been developed on the mathematics of Diophantus back in 200 to 300 AD. He was a mathematician who just liked finding He was very curious about rational numbers, and he wanted to work out how he could discover more. So he created this thing called an elliptical curve. It's a basic mathematics equation. And with that elliptic curve mathematical function, he is able to then able to derive more rational numbers. This is good for computers because rational numbers, computers like, they're not fractions. Two rational numbers make a fraction. But essentially, without getting really into the nuts and bolts of this, this is an example of an elliptic curve. The one on the bottom down here on the right, this is actually the one used by browsers and blockchain. They use an equation, which is this one here. But essentially what it is your private key is a dot on this curve. And that's pretty much how cryptography works. So when you create a private key, like I said, it's just a large random number that plots a point on this curve. And then what happens, there's a starting point on the curve. And then you use your random number that you just generated, and you actually multiply it by getting the tangent of that curve, using the intersection, reflection, tangent, the number of times of that number you just came up with, which gives you then your public key, if that makes any sense. So essentially it's a matter of moving around this curve, the number of times of your secret number that you came up with, they'll give you your public key. And then mathematically, you can actually prove that the private and the public key actually work together. Once again, I'm not going to go into the real details of this, but it's just, I guess, to me, amazing how something so simple is actually securing all the computers of the world today by just using this simple elliptic curve created by a mathematician 1800 years ago. Why are they cool? So they're very cool because the reason why everyone latched onto this is because computers, they can calculate these elliptic curve calculations very fast. They can be used to perform hashing, and they can be used to form those cryptographic keys. It's easy to basically multiply those points on the curve to get to the public and private key. And that's why we use them today, because it speeds up the way we communicate, but still does it safely, but without people seeing what's going on, like your bank transactions. Okay.
Question.
Yeah, sure.
So to use that private key is a dot on that graph.
Yeah.
And then you get the public key based on the equations doing some manipulation.
So I can explain a bit more. So this equation here, for instance, will draw this curve here. And so that's just a curve you draw with all numbers in existence will get this curve on a graph. So to do crypto, when they talk about this SECP 256K1, which is a common one, what that is an agreement that that's the equation and providing the starting point on that curve, right? So everybody knows that. They know the starting point on the curve and they know the equation. So when you come up with a random number, you can start there on a bit of paper and write down a random number up to 256 bytes, 202 to the 256, and that's your secret number no one knows. You then basically find the tangent at that starting point and you get that dot. You then reflect it and you get this dot. So that's 1. So now you do that, the number of times of that magical number you just came up with, and the point you end at could be over here. That's your public, which is the coordinates. So you can give someone that, I'll just mute Elliot there, sorry. So that number you end up with on the curve is your public key. So you can give someone that key. They cannot go backwards around that curve. They cannot, there's no way of actually reversing what you just did to get back to where you are to count the number of times it was done. And that's the beauty of it. Yeah, it's irreversible.
So is it because mathematically irreversible, or it's because the computing power is?
No, it's mathematically and computing. So if you're going to, I guess, brute force it, you wouldn't actually try and go backwards. You'd essentially have to go forwards until you end up with that same key, which is too hard. Yeah.
Cool. Okay.
Cool. All right, so that's it for the propeller head stuff. We'll get back into the blockchain, but it's important to know those two things to understand why the blockchain is actually that secure. As I mentioned just back here, if you go down to this one, it's about a professor at MIT. He does a pretty good explanation of this, and it is really interesting stuff, I guess, for nerds like me. Okay, so how does the blockchain work? First, you need to pull it apart. Just like I always did when I was young, I'd pull things apart because I wanted to know how they work. So I'm going to talk about the pieces, and then we'll slowly put it together to actually create the blockchain. So the main parts of the blockchain is a crypto wallet, which is a proof of identity, essentially on the blockchain, to say that you own something or you are the person who did this transaction. You have a network of computers called nodes. You have a storage, which is called the ledger. There's usually a currency because no one does a transaction for free in any world. So essentially it's used, essentially we'll call it fictitious coins and tokens. So to perform a transaction, you have to give something to transfer a value to somebody, and also to pay for a transaction. You can have logic on there. So logic is really called smart contracts that came out with Ethereum and many other blockchains coming out today. But Bitcoin actually doesn't have smart contract logic in it. You've got real world inputs. So when you start getting into smart contracts, you want to make decisions, and a computer can't make a decision on its own without real world inputs. So they're called oracles, and I'll talk about them a bit in this presentation. Then you have applications that run on the blockchain, which are usually called DApps, distributed applications. There's the security, which we just went over, and the consistency mechanism. So how do transactions become complete is the consistency mechanism, which is also called the consensus. So just getting back into our keys here. So if any of you have gotten into crypto or generated your own wallet, you would have seen this bit at the top here, which is a set of 24 words. So a crypto wallet, like I said, it's just that private and public key. So your wallet, it sounds all scary and people talk about wallets on the computer, but a wallet is just that private key, and that public key is what you give to everybody. So to make it simple for humans like us, instead of saying come up with a really big number, they use this thing called a seed phrase. So where are we? The bit that usually is used on any blockchain is this bit 39 standard. So it's a standard list of 2,048 words that people came up with, saying you can only use these words in a seed phrase. Each of those words represents a byte. So when you come up with your seed phrase here, using any of those 2,048 words, that actually then converts to bytes and generates that magical secret key. From that private key, you generate your public key, and that's your wallet. It's as simple as that. It may sound really odd that, wait a second, only 2,000 words, how is that unique? But if you do the maths behind it, generating any of those random 2,048 words has, and I'm not even going to come up with this number, but that's the number of permutations that you can actually generate from a 24-word seed phrase using only 2,048 words. So it's safe, it's very secure, and it hasn't been cracked to date. Just to sort of show how magical this is, you may think, well, to get onto the blockchain and to do a Bitcoin transfer, I need to actually have a computer. You can generate this with a calculator. You can generate your private key and your public key using a calculator on your desk. You can then give someone your public key on a piece of paper. They can send you Bitcoin. No one can take that Bitcoin from you. It's being sent to your public address, and only you with the private key can spend that money. And you never touch the computer. So it's that impressive that you don't even actually need to be on a computer, and you can still receive Bitcoin. All right, I'm getting a croaky throat, so I might need to pause at the end of this one. So what makes up a Bitcoin block? So now I'm drilling into what are the blocks in the blockchain and what is in a block in the blockchain. So this is largely based on Bitcoin, but it is very similar to most of these technologies. Every block has a header, and it has transactions in it. Oh, Roshana might just mute you there. And what makes up that header? So first thing is you have a hash at the top. So this is a hash of the contents of the header of this block. So hashing that information in the header gets you a hash. After that, inside the header, you have the hash of the previous block, which is how we're getting into the chain, putting the pieces together here. So this is a hash of the previous block in the chain. We also have the hash of the transactions in this block. So we're hashing everything in here and we're putting that hash up there. We also have a timestamp, how big the size of the transactions are in bits. And we have a thing called a nonce, which I'll cover a little bit down. This is the magic of everyone says that there's a problem that these computers need to solve. This is the key to what it is. So within the transactions on every block, predominantly on Bitcoin, but it's also the same on Ethereum, is the miner's reward. So obviously, whoever solves that block gets paid money. We all know that. That's why you have Bitcoin miners out there, churning away, because there is a reward. So for you to build this block and to put it on the blockchain, the people putting these transactions in the block will actually tip you a value of money. And that goes into this Coinbase transaction. When the node creates the block, it'll take all those amounts, put it in here, and put their wallet address in. So once that block's minted on the chain, not minted, when it's confirmed on the chain, now that person got paid for generating that block. Then we have our transactions. That's you and me sending each other money or performing a smart contract or whatever it is. So that's the makeup of a block. I spoke about here the Merkle root, which is the hash of the transactions. It's pretty unique how this works. What actually happens is every pair of transactions gets hashed, and every pair of those hashes gets hashed until we end up with the Merkle root. The reason for this becomes more, when you dive a bit deeper into it, the reason for this is the way that all transactions forever take up a lot of space. And if you use this mechanism, spent transactions in the past can actually be removed, but still maintain the integrity of the blockchain by using this mechanism. I won't go into the details, but that's pretty much how it works. So how do we chain these blocks together? As we hear, it's called a blockchain. The reason for it is those blocks are chained together. So it's as simple as the block, you start off with the Genesis block, and the Genesis block is the first block that's ever mined on a blockchain. After that, the next block will always include the hash of the previous block. And then the next block, and because that hash is inside the header, this block, when you hash it for the next block, you're now chaining them together, because you can't modify that now, because if you modify it, that hash will be different, that chain will be broken. You can't modify this block because that hash will be different. That hash there will be different now to what the hash of this block actually is, and the data doesn't chain together. So the way the computers on the network, they're constantly checking every single block in the chain, they're hashing every single block, and they're verifying that every block is consistent and unmodified. And that's going back to that hashing. So you change one character in any block and the chain will actually break, and all the validators on the network will see it, and they'll actually throw your node out and your block out. So any change to a transaction will invalidate the whole chain and make it invalid. I'll get into what the nodes are. It's pretty straightforward. So everybody essentially is running is managing the ledger, and they're taking transactions and they're adding blocks to the chain through a proof of work or a proof of stake mechanism. And they've all got a copy of the same data, and they're always validating that chain is consistent. So putting these pieces together now. So Bob wants to give Alice Bob wants to receive money from Alice. So Bob gives his public key to Alice. Alice then goes in and she'll unlock one of her original coin transactions that she received coins from. She will then create a new transaction and put Bob's private key in. And then that allows Bob to now unlock it with his private key. Sorry, I've gone really wrong here. So I've said it right, but in the wrong order. So essentially, by Bob giving Alice the public key, that's the address of his private key. She can then wrap a transaction up from her coins she had previously. She can create a new transaction with Bob's public key in there and say, Bob now owns these coins. No one can now claim ownership of these coins without having that private key. So now Bob is able to use this transaction here to say he owns those coins to pay somebody else in the future. And that's those transactions are happening within those ledgers now, within those blocks and by those nodes on the blockchain. Just now stepping back once more, like zooming out a bit, we'll put these pieces together, what we've learned so far. So we've now created the ability for anybody to send anybody, create a transaction on the blockchain. They can send it to any node. Those nodes will commit that to a block. In here, the transaction is sent to a node. So I've corrected this. This was a graphic I got off the interwebs, but it's actually incorrect. So the transaction is sent to a node. Those nodes will then decide if they want to add that to the next block to solve the mathematical problem, to be able to just claim the next block on the chain. They'll then publish that to the rest of the network. It will then say, let's check that block and see if they did solve that problem. And if they have, I'll add it to the chain, which means they end up with a consensus, the blockchain starts forming, and that transaction is final. I'm going to pause for a second. Oh, yep. Sahal, do you want to ask a question so I can get a breather?
Yeah, sure. James, in one of your previous slides, you mentioned something about the Genesis block, which I understand is the mining, when you solve some complex calculation and you generate a Bitcoin. What I was not able to understand is that when you actually trade a Bitcoin, it's always in fractions. So how does the Genesis block actually get fragmented into multiple pieces and still maintains the integrity of the hash?
Very good question. It depends on the technology. So if we talk about Bitcoin, if I just go back to Bob and Alice's transactions, I've actually forgotten the acronym, but essentially the way Bitcoin works is there's no such thing as actually generating a Bitcoin. Like it's actually not the way it works. So there's a miner's reward for mining the block, and that's a reward that's set in the algorithm. So that's how coins are being generated. But all it is a transaction that says that, so if you mined a Bitcoin, let's start from the Genesis block. So you mined a block, you get given, let's call it 1 Bitcoin. What actually happens is it all started back here. It all started back here in this Coinbase. Because I've mined that block, I now get coins. That's a transaction now in history saying that my secret key and my public key owns the transaction, and that transaction was 1 Bitcoin. So when you actually go to spend Bitcoin, the miner's actually looking back through the transaction history to say, where does James have coins? And it will say, okay, well, he was getting coins here. And when you actually put a new transaction on the chain to say, it's back here, if Alice is paying Bob, she's actually putting a transaction in. And if you drill into that transaction, she is pointing to a previous transaction where she got given a Bitcoin. And in that transaction, she'll say, I'm going to give Bob half a Bitcoin. And the other part of the transaction is I'm also giving myself half a Bitcoin. So what that does is that actually burns the original transaction of 1 Bitcoin and now creates 2 transactions saying Alice gets half a Bitcoin, Bob gets half a Bitcoin. So that's how, I guess, Bitcoins are managed on the blockchain. You're actually using a previous transaction where you were given something to then spend, and then the new transaction takes the form of what's remaining, and the old transaction is then essentially null and void. It's finished because the money's been spent.
So basically you're spawning 2 transactions out of that 1 previous transaction.
Yeah, so there's in the references at the end of this, there's a really good video series where this guy actually walks through Bitcoin itself and how that works. And it's really interesting because no coins are actually generated, just transactions of things happening. So when you mine, you get given a reward. When people want a transaction to be done on a network to make it more enticing to happen quicker, you pay a bigger tip, they call it, which is essentially a transaction fee. And that means then the miners on the network are going to pick up your transaction before anyone else's because they're going to get more money for it. And all those tips end up going into that original transaction, which is that Coinbase transaction here. So that person gets a reward of all these transactions, and his transaction will actually say, credit all of those tips into my account. And he can't overspend, because when that block gets pushed out to the networks will always check that all those tips add up to the amount this person's transacting, all that's valid, the hashes work, this problem was solved, it gets committed to the blockchain, or it gets thrown out.
Thanks.
One question.
Yep.
Could be a bit dumb question, but is it publicly transparent, like how many Bitcoins are circulating? Can we see how many coin they acquire? Oh
yeah, definitely. You can. There's things like Etherscan. You can go and see any wallet on blockchain, on Ethereum, on Cardano, any of these blockchains. They've all got. They're called block explorers, and you can actually go in there and see. But all you're seeing is a public key. So you're not seeing someone's name. You're just seeing this public key here has 10,000 Ethereum coins. So that's the anonymity of blockchain, is you're just seeing a random number owns coins. You don't know who it is. But what these are, if you go to, I've got some references at the end of this, but if you go to say Etherscan, people have started sort of saying, well, I know that wallet is actually owned by Binance, because people want to know, is money going into the exchanges or out of the exchanges? So over time, people work out who owns what wallets, like Satoshi Nakamoto, obviously first Bitcoin transaction, they know that's his wallet. So there's a level of anonymity, but there's also a level of openness, because you can actually see every single transaction ever made on Bitcoin, and you can see from what wallet to what wallet that occurred. So the way just to jump into that, to prevent fraud, so when you end up getting BitLocked, your machine gets locked and they say, pay me 10 Bitcoin now, or I'm going to delete everything on your computer. What the governments and crime prevention has been doing is they know the wallet that Bitcoin's getting paid to, and the demands across the world to pay into that wallet. They can't stop that from happening, but what they can do is they can publish that to all the exchanges around the world, like to cash out, essentially, to say this wallet is fraudulent, it's organized crime, whatever you want to call it, and then the exchanges will actually prevent to cash for that person to actually turn that into money. So that's how they prevent it.
So it's actually the one who convert that wallet into cash, or someone who's trying to sneeze. It's his responsibility to say it's fraudulent or not. Okay.
Yeah, some people have been burnt because they do sometimes go an extra step. So that fraudulent person then actually says, hey, Rabin, I'm going to give you 10 Bitcoin, give me 10 grand in cash. And you go, cool, I'll do that because that's half the price. You end up with those Bitcoins, but there's a trap now that 10 Bitcoins came from that criminal's wallet into your wallet. The exchanges will actually ban you from cashing that Bitcoin out because that's come from a fraudulent wallet. So there's a lot of protections, and you can check those things over time to make sure that doesn't happen to you and you receive funds that you can't cash.
Thank you.
Arkady, did you want to ask a question?
Yeah,
I'll get on the list.
Yeah, not a question, just a comment to Sahil. If you want to, there is a cool stuff that you can learn if you want to look how the blocks works, is to install the easy miner and start to debug it. And that way it will show you how the blocks works. You won't be able to crack anything because it's quite safe. Well, it's safe to say it's safe, but you can see how the blocks works and etc.
Yeah, if we get some time at the end, I'll show you a good graphical website that actually shows you the real-time blocks and you can actually drill in and click through the block and actually see how it all comes together. It's really cool. So I think you had your hand up there. Oh, by the way, you can put your hand down if you've sort of didn't want to ask a question or change your mind.
Yeah, so look, again, it's not a question, it's more of a comment again on Rabin's kind of a question. Either for every blockchain, can we find it out that how many coins are being generated and how many are, because there are two concepts. One is how many have been generated and how many are in the circulation. So yes, for Bitcoin, that capability is there. You can find it out that how many have been generated on the blockchain itself. But of course, for the circulation, because over the time period, the coins or the people have lost their wallets or they kind of a comeback. So of course, the circulation is the one which are actively being used. You kind of in that sense. So that is more of a projection. Like you can't find the exact number of the circulation, but it is more of a projection that this is an estimated number of. But of course, the number of coins generated, yes, Bitcoin has that capability to find out.
But Sohail, you were saying like the circle, like we know like how many like coins are there in the market, how many being sold, how many being like somebody is buying it. From that, we can't get to know the exact number. Like if
no, I'm saying that we exactly know that how many have ever been created or kind of calculated so far. As James mentioned, that it's not that we are generating the new one. It is all the number kind of a manipulation, you call it. So in that sense, yes, we can. We know that how many have been generated so far. But I'm saying that the calculating the current circulation is a bit tricky. Because one is in a circulation. Because what happens is that, for example, Satoshi's wallet, that is never being used. So that is not in a circulation at this stage. Circulation means which are active coins, which being used.
So circulation means like how many are there in the market which are getting sold or bought.
Yeah, people are using it for some purpose. Not, and moreover, it's not just that I can only use it for selling or
buying or doing. You can do some
cases as well. I might have staked it somewhere to earn a percentage or reward on that, or earn an interest on that. So that's one thing. But just a last comment on that. But not every blockchain has that capability. For example, Ethereum, at the moment, there is no mechanism to find it out how many total Ethereum is in circulation or being generated, because they never built that capability. And
but I guess before we go too deep, what I was going to do is see how interested people are on this topic, because I guess what I was covering here is just the mechanism, not the tokenomics. But I think, I love the tokenomics behind it. But maybe I can do it. We can do another session, and so Habe, you probably know more than me about it. Is just how do you analyze the blockchain? How do you view transactions? How do you know what's in circulation? That type of stuff, which is a bit more of the exchange behind it. Jing, I think you still got your hand up there. Jing. Jing.
My question is more the mechanism. So when a transaction is written to a block, who gets to mine it or solve the puzzle? Like, is whoever solve it first quicker gets the bonus, or it's
I'll get into the puzzle, because the puzzle escaped me for a long time, and for some reason it's not really publicly explained or anything like that, but I'll explain it here how it works. But essentially anyone can solve that block, and anyone can put a transaction on the blockchain if they solve the problem, which I'll show you is quite a simple problem, very basic problem, but mathematically works geniusly, to the point that in blockchain there's mechanisms to slow down how fast that puzzle is solved, to ensure that Bitcoins are generated at a regular pace over a long period of time, so that essentially coins aren't just created out of thin air. I won't go into the Bitcoin mechanism, but I will talk about what that problem is, how it's solved, and how it ensures that you don't end up with everyone on the network saying, "Hey, I've got a block, I just spent money." Like it's called the consensus. I'll cover that in a couple of slides. Cool. All right, I'll go into the next section now. I think it's the next section. So I'm just going to jump into the OGs of Bitcoin, which is Bitcoin and Ethereum, a blockchain, Bitcoin and Ethereum. So Bitcoin is really one of the first. The reason it was created was it is just a crypto exchange of value. So coins as value being exchanged between parties. That was created by Satoshi Nakamoto. That's not his real name. And without getting into all the detail, nobody knows who Satoshi Nakamoto is. They sort of a lot of speculation of who it might be. But he was frustrated with how countries just printed money, companies generated money out of thin air. And he sort of just, he didn't agree, said it can't be sustained. And a lot of, other people in his community sort of said the same thing. So he went on his way to sort of say, how do I, build something which exchanges value, doesn't suffer from inflation, and is a way of people transferring value between each other. So that was the white paper on Bitcoin he created. And then he actually built Bitcoin largely himself, but with others. And in 2009, he minted the first block, which is that Genesis block. And in there, he hit a little message in the transaction saying the headlines of the UK newspaper was basically Chancellor on brink of second bailout of banks. So it was more of a thumb at saying, there you go, you're printing more money again. On the right here is just a little diagram just showing you in 2018 where Bitcoin sort of sat in putting money into perspective. If we look at it today, Bitcoin's here. It's valued around $1.5 trillion. So it's not a flash in the pan. It's not, I think more people who probably don't understand the technology and how the value is defined in Bitcoin sort of shoot it down. There's a lot of discussion, and I'll sort of go into a little bit of it. I don't really want to have a battle. I just believe it has true value. An interesting point, though, is how did they come up with the value of Bitcoin? The value of Bitcoin was first placed when they started mining coins and trading coins and just sending coins to each other and having fun. They wanted to put a value on it. So one of the guys in the community said, hey, why don't we just put the value on the cost of electricity to generate, to mint a new block and the reward for that block. And that actually defined the price of Bitcoin, was how much electricity it cost to actually create a new block and get the reward. Since then, obviously, it takes on a value of its own, similar to gold, similar to the US dollar, where people believe the value of the underlying asset and what it's worth, and will pay for what it's worth. The other OG would be Ethereum. So Ethereum took what Bitcoin did really well, but decided that, well, you need to have programming in it. You want to be able to have contracts between people. They probably didn't know what they were creating at the time, but by creating they created the program language in Ethereum that sits on the blockchain. So any program you write becomes a transaction in a block, and that transaction is code, and that code will be executed. What that actually allows people to do is trust that that program can never be altered, it can never be changed, and everyone can see what that program does. So when you enter into a contract, you know what's going to happen, and there's no way anyone can change that. So, a smart contract could be an agreement to pay someone next month 100 Ethereum. You know that contract will only pay out next month. They're not going to get it tomorrow. And when next month arrives, they will get that money. And the person receiving that money can be assured that next month I will get that money because I can see James put 100 Ethereum in there. That contract's complete and the program will execute next month and pay me that money. So it's a way of two parties who essentially don't trust each other can get assured that on execution of that program, they will get the reward or the value. On the right here is based on just building that new blockchain with the Turing Complete programming language, has given birth to all of these companies, all of these applications, all of these products. There's service products, there's new types of coins that are pinned to the US currency called stable coins, or many different currencies. There's asset management tools, there's exchanges where people can actually trade. So it's just blowing the top off really what blockchain can do now. This is an explosion of that diagram. And moving on to, I won't get into the layer 2, which is I guess the new birth of Ethereum, moving to be able to process more transactions a second, is called really layer 2. And that's now given birth to another ecosystem of sub-blockchains on layer 2. So let's get into a bit of the consensus now. So the consensus is, how do we know who can actually generate a block and add it to the chain? Obviously, if every node said me, you're not going to have a stable chain, and you're not going to know why a transaction happened, or you just won't get consistency. Because you think about it, you've got thousands of nodes on the network all trying to say, we're all going to keep our data consistent. So you have to slow down who's actually deciding the next block and giving time for that to propagate and get that added to all the nodes on the network to create that chain. How do they do this? There's two major consensus mechanisms. One's called proof of work and one is called proof of stake. So proof of work was the first. That's what Bitcoin started with, what Ethereum has. But a lot of people are now, or a lot of projects are moving towards proof of stake. So why do we need consistency? I'll go into what these two mean, but why do we need consistency? It needs to ensure that the blockchain, all server nodes participated in the blockchain must keep a consistent record of the chain and decide which node can add the next block. This is a challenge, obviously. You've got latency, you've got time drift, maybe not possible to connect to a node over a period of time. You also need to trust the other node is doing the right thing. So you do that through the consensus. So proof of work. The proof of work is a consensus where the validator on the blockchain needs to solve an incredibly hard problem to win the right to create that block. Once the block is created, the validator also submits the proof of work to all the other nodes and says, hey, I won, I solved that mathematical problem, and I get to put the next block on the chain and claim that reward. That's all you ever hear, is like, it's an increasingly hard problem for computers to solve. Well, here is what that problem actually is. That's really cool. So if we look at blockchain, the problem to be solved is all around cryptography and hashing. So essentially, blockchain will say, you must ensure that the hash of your block that you're creating has a leading number of zeros. So that leading number of zeros will decrease or increase. And what that decreasing or increasing means is, if you say it has to start with a leading zero, it's a lot easier to actually change the block enough to get just a zero at the front and say, hey, I get the right now to put the next block on the chain. So to make it harder, as computing power gets higher, they add zeros to that. So it's increasingly hard for a computer to modify a block enough to get that magical hash that no one can derive without actually doing it, to lead with that many zeros. So this is actually an example of where Bitcoin's currently at and how many leading zeros you need to produce, which is essentially that is the hash of this header here. So computers will sit there with their graphics card or their miners or ASIC miners, which are CPUs designed to just hash. And how do they do that? They can't change the previous block hash. They can't change the version. They can't change the Merkle root, which is the hash of all these transactions. They can't change the time. They can't change the bits, because all those transactions, they never change. So what they do is once again, there's two methods they can do, and generally they choose this one I'm going to show you. They can actually swap out transactions, but that's too expensive, because if they go, okay, what are the transactions are people submitting right now? Maybe I'll pull one out and put one in and see if I get that hash with leading zeros. There's a lot of computing power in that, but what they'll do is they change this thing here, which is called the nonce. So just by starting at 1 and then going to 2 and then going to 3 and then going to 4, and changing that number and rehashing the header and checking if it starts with leading zeros. No, it doesn't. Increment, hash, leading zeros. No, do the same over and over and over again. So as you can see here, that hash is very good for graphics cards and ASIC miners. That's what they're built to do, just hash. And as you can see, this is actually a transaction on Bitcoin. And here it had to go through 2.9 billion iterations before it could actually end up with those leading zeros. Once it solves that problem and goes, oh, I got it, it then can broadcast to the network saying, here's the next block on the chain. All these transactions are in it. The I receive it, if I'm another node on the network, all I have to do is say, well, is that the hash of the previous block? Yes, it is. Here's all the transactions. Do they all hash up to the Merkle root? Yes, they do. That's pretty much it. Obviously, checking those transactions, the tips in the transactions are the same as the Coinbase transaction, and now hash this, and I get 0, and they all go, yep, that's all good to go, and they will actually put it on the blockchain. That's the puzzle in a nutshell.
So who gets to validate you solve the puzzle? I know you give all the required leading zeros, and then all the other data didn't get kind of tapped. So who will be validating all these things after you say, oh, I got the puzzle?
Yeah, everybody on the network. So all those nodes on the network have a copy of the ledger, and they're not going to add any block to their ledger that doesn't solve that problem. So when this block is now generated, it's got the hash of the previous block on the known chain. This gets broadcasted from the node that solved it to all the other nodes, and then they'll validate it going, okay, do the numbers add up? Does the hash, because no one can get that hash without having gone through the work.
Right.
So once it matches, they just add it to the chain. It's as quick as that.
Yeah, once you got the answer and you broadcast, so every node on the chain will validate it.
Yes.
And then that means after you claim you solved the problem, there will be some time you wait that to confirm you got the right answer.
Yeah. So you'll see that if you've ever done a transaction or transferred coins between two wallets on blockchain or Ethereum, is the first block. Like a lot of people will say, well, we're not like an exchange. We're not going to give you your money until they usually say until the depth of 5 or a confirmation of 5. What that means is once that block goes on the chain, we're not going to give you the money until 4 other blocks have been added to the chain, which shows certainty that that block is now well and truly on the chain. And the reason for that is chains can fork, and they do fork all the time, because 2 people might solve the problem at exactly the same time. And the mechanism then after that is to say, well, they're both valid. They both solved it at the same time. Let's see who wins next. So what they'll do is then see the longest chain. So now it's forked, the longest chain wins. So I think for 2 more blocks, they'll say whoever gets the most blocks off that fork becomes the main chain, and then they actually roll back all the other transactions. Right. So that's why you do wait for a few blocks to be produced before you actually say, all right, I commit to that transaction.
Yep, that's how they solve the racing conditions on same time. So,
and the same thing will happen with smart contracts. If if I pay you $100 under a smart contract, you get your $100. But if that block gets rolled back, it'll actually roll the code back also and give me the $100 back. So that's why when smart contracts are secured, you always wait for the 4th or 5th block to be put on ahead of yours before you say, yep, it's good to go.
Cool, awesome.
Cool. I sort of explained it here, but cool. All right, so the pros and cons of this. So how are we doing for time? Because I've still got about half an hour to go, I believe. So the pros and cons of this proof of work, obviously you hear a lot about it in the news, and probably a lot of it is FUD. But the pros are that anyone can start a blockchain node and participate as a validator in the blockchain and earn a reward. So you could go and put a graphics card in your computer, install some some Bitcoin software, and you're now a validator node on the network, and you can start making money. Not that straightforward, because obviously you've got to pay for the electricity, and that sometimes costs more than the reward. But essentially anyone can participate, and no one, there's no paper to fill out, no online forum to go to, no documents to do. You just install the software and you're on the network and you can get rewards. It's a proven consensus mechanism, mathematically proven, and also 13 years of real world use, and still to this day hasn't been broken. The cons, obviously, it consumes a lot of computing power. That simple mathematical equation is very hard for computers to solve, and requires a lot of power, a lot of compute. Transactions become slower because a block can only have so many transactions in it. So if Bitcoin, for instance, is, I believe it's limited to 2 megabytes each block. So it can only put 2 megabytes of transactions in every block, and every block takes a while to solve the puzzle. which means their transactions per second are a lot lower because you're waiting for these computers to solve a problem for those transactions to be complete. Okay, I'm going to proof of stake. So proof of stake, like the new platforms like Cardano, Ethereum, Polkadot, Polygon, pretty much most of them these days are moving to proof of stake. It is still to be tested. It's you know, theoretically it works. The rules of it work, but a proof of stake is essentially tokens are staked on a node to become a validator. So if you say Ethereum, like if you look at Ethereum level 2, to be a staking validator on the level 2 Ethereum network right now, you have to actually stake 32 Ethereum. 32 Ethereum, I don't know, rough numbers. 32 Ethereum is around $16,000 or $17,000. So you're actually saying, I'm going to be a validator on here, and I'm going to stake my 32 Ethereum so I can be a validator. And the reason you do that is because there's no mathematical problem to solve now, because you're saying, well, just by staking those coins, you're now a validator. The way they work that, you know, into the consensus is saying essentially if a transaction passed around by a validator is actually found to be fraudulent, it's not performing, as in it goes online, offline, becomes unavailable, it's not a good player in the network, you get penalized. They start the rules of the program will actually start taking those 32 Ethereum tokens from you, saying you're a bad person, you're a bad node, and actually will start slashing your wealth. So it's really saying put up some money and prove that you're honest to be a validator. And if you're not honest, you'll lose those coins. So it's a proof of stake saying I've got proof of money. I'm putting my money where my mouth is to be a validator here, and I'll get rewards for doing that because I get, every time I'm into block, I get rewarded for that. It allows for faster transactions because now blocks, usually the way it works is all the staked nodes on the network, you know, there could be 1,000. Any of them can solve this, can mint the next block, but what happens is in the rules, it'll randomly select a node to say, this node here is the minter of the next block, then randomly select the next node and the next node and the next node, which means all they have to do is generate that block, put it on the chain, I'm done, pass it to everybody and move on. So more transactions can be processed a second. And the risk is losing your stake. The other, I guess, protections around doing proof of stake means that, you know, for someone to take control, which is essentially 51% of the nodes on that network, would cost a huge amount of money, because obviously if you would say Ethereum level 2 is say 1,000 nodes, it means you have to do 501 times $16,000 in staking to actually take control of that network to do a fraudulent transaction. And what would you do that for? Because now you've taken control and done fraudulent transactions, you've just devalued the entire network and lost all your wealth. So it's that basically, you know, you're not going to sort of do anything dodgy because you'll lose money or devalue the whole network and lose the money that you staked anyway. The pros of this means fast transactions, scalable into the millions of transactions per second. Theoretically, I think they're up to, I think the best is 1,500. It's cheap to operate because you just need a computer, not something with a big mining rig, which costs lots of money in electricity and hardware. You can just run it on a PC. It's theoretically proven, but still early stages and real world proof. And to participate as a validator on the chain, you need to have collateral. So it's sort of raising that barrier of entry from anybody can be a validator to, well, you've got to have some cash to be a validator. All right, does anyone want to ask any questions just yet? All right, I'll move on. I'll talk about the features now. So let's get into, you know, we're moving another step up now. We're going from all the techo stuff up into the actual, you know, the functions and features of this. So just to explain, there's coins and tokens. They're generally interchanged, but I guess you know, if you want to be a purist, coins are essentially referred to as the native token. So Bitcoin is essentially the native token of the Bitcoin network. Ethereum is the native token of the Ethereum network. So they're the coins that blockchain network used to actually perform transactions, to trade value, etc. And then you can move into these things called tokens. So largely this came out with ERC20, which is a Ethereum request for comment, a new change to the Ethereum network to generate these things called tokens. That sort of created the whole boom that we see now, which is people created tokens that are backed by US currency. So USDC is actually backed by a company that for every USDC they mint, there's a US dollar sitting in their bank account, somewhat still being audited, in the bank account that represents that USDC coin. So that allows then people to actually trade and buy and sell using USDC coins to buy Ethereum and USDC coins to buy Bitcoin, because everyone knows that that's as good as a US dollar. And then it's used in exchanges where they'll actually give reward tokens, which become valuable because they represent the actual the application and the ecosystem, like Uniswap. So Uniswap is a way of trading coins, and people get Uniswap rewards like Uni tokens. But those Uni tokens actually have value now because they really represent the actual, you could say, the company of Uniswap. So yeah, they derive value from the asset, I guess, that's producing the benefit to the community. So that's the difference between coins and tokens. Smart contracts, I've talked about it a bit, but a smart contract is essentially a program that takes assets and data, runs code, assets and data from either party, and then spits out assets and data based on the logic in there. That's really all it is. It's a program that runs, but being a program, it can do anything. You have oracles. So oracles are a way of actually connecting the real world to a smart contract. So obviously, think of an insurance policy where you could create a policy to say you can buy insurance that if it rains less than 5 millimeters in your area, will automatically pay you an agreed amount. So to ensure that the contract will pay out automatically and no one can influence it, you would use an oracle. So oracles, like Chainlink is one, they'll actually take, say, the rainfall data from probably about 20 different sources on the internet from trusted sources and take the average of those 20 sources to provide, this is what the rainfall is. So oracles are trying to take the real world, which can't be front run, which is people can't anticipate what it's going to be before it is. And also they're taking it from multiple sources, so it can't be corrupted. And then smart contracts can be written to say, well, I'm using this oracle to get the price of a stock on the NASDAQ, and I'm going to sell you that stock is going to go down by $10 in the next month. So then people can say, well, I trust that oracle. It's getting data from a valid source, so I'll enter into this contract. If the stock goes down, you get paid out. If it doesn't, they get their money back. So it's a way of attaching real world to, I guess, the blockchain. NFTs, the hype at the moment, huge hype. So NFTs, what is an NFT? It's a non-fungible token. So the best way to illustrate this really is you've got this matrix here, which is essentially fungible, non-fungible, intangible, tangible. So let's just look at what a non-fungible is. So the best way to explain it is tangible and fungible is currency. So if you had $10 and I had $10 in a $10 note, you can actually give me that $10 note, I'll give you my $10 note, and essentially we've got the same thing still. It's got the same value of $10. So that's what a tangible and fungible is. It's interchangeable. Pretty much many things represent the same thing. So many $10 notes represent $10, but non-fungible is unique. So think of a piece of artwork like the Mona Lisa. That's not fungible. You can't have another Mona Lisa. A car can be, because once a car is worn, you can't reproduce that worn out car with the bald tires on the front but not the back, etc. That becomes a non-fungible asset. So non-fungible tokens at the moment, I think, is it's a hype curve. Everyone's sort of into it, where people are creating electronic artwork and then getting the hash of that electronic artwork into a smart contract saying, do you want to buy and own the rights to this artwork? And people buy that, saying that, well, now I have the rights and I own that artwork. So they're creating these things called non-fungible tokens and actually trading them on exchanges to buy and sell essentially at the moment artwork, intellectual things. But really where it's going is, you know, the NFL are getting on board, Christie's auction house is getting on board. Essentially, even the first tweet was sold for $3.8 million as an NFT. So where it can go from here is it could represent land ownership in the future, where you basically everyone's land ownership is an NFT. And when you sell a house, you actually, by buying that NFT, you now own the rights to that land or that property. It can be used for digital rights management or ownership of music, registration of a vehicle. It can be many, many things. The sky's the limit. It's really what's happening now in the NFT space is pretty cool and pretty fun. But where it will go, you know, is actually, you know, the essentially the title of ownership in the future to many things, and the proof and public proof that I can show that I own that, because once again we've done a smart contract exchange. It's cryptographically safe. I have my private keys and can prove that that transfer is owned by me. Blockchain applications. Does anyone want to ask any questions yet? I'm very close to the end, wrapping up now on the home stretch.
I have one question.
Yep.
It's about the proof of stake. So
yep.
The penalty, where does the penalty money goes to? Is compensate the transactions on their block, or it's going to somewhere?
The penalty, it's built into the rules of the blockchain. So all nodes will behave within the rules. Really the program, when you look at it, like, you know, for you and me, you're installing the Ethereum blockchain engine. That's got the rules built in, but it's an agreed set of rules that have been voted on. So it's down to the point of, if a node is unavailable for X number of days, then they'll be slashed by 5%. And then basically, because all the nodes in the network know they couldn't reach that node for X number of days, automatically they'll slash, the next miner of the block will actually slash their funds by putting in a transaction saying from this wallet to, I think it gets burnt. So basically to a wallet no one owns, money gone.
No, James.
You'll know better than me, Sahib.
Yeah, not in every kind of a blockchain. In some blockchains, what happens is that because this is being created by a specific centralized company or the team, you call it.
Yeah.
What they generally do is that they form, there is a new concept called DAOs, which is
the DAO. Yeah,
which are the distributed autonomous organizations. So these are, and moreover, like these DAOs are more of a giving the power back to the community that, okay, you guys are going to make the future decisions that where we want to get this protocol or blockchain to. Whatever that needs to be made into this blockchain are going to be approved by the DAO itself. So what they do is that then, of course, the DAO has its own wallet. So all these penalties goes into the DAO wallet. Kind of called the treasury. Treasury means that, okay, now they got the funds by analyzing the kind of the fraudulent and all that. And that fund, now community has to decide where they want to use it in the future, for which feature, or they can give a grant to the other teams who can build further applications. The point is that fund can be utilized for the enhancements of the blockchain in the future.
Yeah, I didn't actually touch on that. That's probably a good thing to go into later. But yeah, essentially to become a part of the DAO is fairly simple and I guess once again open. You basically just hold tokens usually like Cardano, and you register as a voter. And then you're based on the number of tokens you have is how big your vote is in the DAO. So you're actually, anyone in a lot of these can become a part of the DAO. As Sahib said, is that DAO, generally what they'll use that DAO for is to fund startup companies to build dApps or distributed applications on their network. So they'll fund new development works to pretty much make their blockchain more accepted and widely used.
What does DAO stand for?
Decentralized
Decentralized autonomous organization.
That's right. Yeah. So like a
Yes.
virtual company.
Yeah,
Yeah.
but the edge is with the DAO is that look, there is no central authority, and that's where
Everyone votes, yeah.
yeah. So that's where like generally the power is being given back to the community or the token holders, because most of the, as James was explaining, that don't think that every coin is a currency. Like Bitcoin is a totally different story. It has a store of value aspect and all that. But as compared to this one, not every coin is being used as a transfer of value. Most of the coins which are now being created on the blockchains, they are more of a kind of a governance token. For example, the Uni token, which one of the token from the Uniswap, and that is a governance token. So what happened is that they have a regular meetings where they decide whatever the new proposals are, and then the token holders vote. So let's say one token is equivalent to one vote. So that gives you the power or a kind of a authority to participate in the DAO. So they are more of a utility, but now because the ownership is getting distributed and people want to participate into such protocols, that brings the value, because of course there is a limited supply and there is a demand that, okay, we want to be part of this protocol, but you can only be part of the protocol if you own a token. So that's how those kind of a governance token accrue kind of a value.
Yeah.
Right.
Cool. Yeah, I think it's certainly. I'll finish this up. But one thing I've sort of Sohaib and I and Prashant, a few of us have discussed is like if everyone's interested in this type of stuff, like I was thinking of sort of creating almost like a catch-up session where we can sort of talk about new things that are emerging or things to watch because it's pretty exciting times. I see this almost like as the internet. I think back to when. CNN and all that were saying, so what is the internet? Like, what is this they're all talking about? Like, that's where blockchain is right now. It's still, people don't know what it can do, what it is, what it's there for. Some people are saying it's flash in a pan, like they said about the internet, but the practicality and everything's lining up to say that, no, this is almost like the next generation of things to come. Cool. All right, I'll move on.
James, I had a question. Sorry, just while you're on NFT, and you mentioned that these NFTs can be like the first tweet was sold as an NFT. So how practically is it like that? The tweet is digitized, or rather, a tweet is digital anyway. How is it digitized?
Yeah, it's still got to be, still got to meet the real world criteria. And this is where, there's always the hype phase, I call it, which is, well, I don't call it, that's a thing. The hype phase is when everyone adopts a technology and uses it in really weird and wonderful ways, some impractical, etc., but everyone just wants to be in it. The hype curve will end up with a lot of people who suffer as well because it will drop off and then it will become practical. So essentially what they'll do is like, I've forgotten his name, the owner of Twitter, he actually basically says, here's my wallet. I am the owner of this wallet. I'm going to sell it. I think he sold it through Christie's originally. So he'll sell it through a reputable place. And then you can see on the blockchain, well, that wallet has that NFT, which is proof that that is him. And he's essentially maybe got the hash of the first tweet. I'm not sure how this particular one was sold, and creates that NFT also to say this is the first tweet. And then it's all trusted, as in I know that that's coming from the real person, and then they'll sell it. And then from then on, it will be traded, knowing that that is the proof of rights for that original tweet.
I'm just thinking that what stops him from creating one more NFT called first tweet?
No, well, that's the thing. It's in the smart contract what it is. So that's where I was sort of saying people have to be careful what they're buying, because when you're selling that first tweet, what is actually being sold? The rights to it, the rights to actually publish it, to be able to, if any news organization uses it, I get royalties, etc. Or is it just to say that I own the first tweet? And this is where I think things are going to come undone. Like you've got the NBA who are selling actual classic video shots of their famous basketball star doing a slam dunk, and are selling them as NFTs, like the rights to that video. But when you actually look at it, you don't own that video. You just have the right to say you own it. So you will never actually earn royalties off it, and the NBA still own it. So what are you actually buying? So that's where you've really got to be careful of what is the NFT and the trust of the NFT to know that you actually do have ownership of it, of well, you have ownership of it, you can prove ownership of it, but what is the underlying NFT contract?
Exactly.
Yeah.
And the value also comes when we have legal stuff to protect it, right? Like the Stephen Curry, he bought the NFT avatar, he owns it, but I've seen a lot of people using the same avatar on internet. So
Yeah,
to
and
have
the
the
thing is, you've
value
got to
of it,
protect
you have to like sue them if they can't use it because I
Yeah,
own
that's
it.
the thing. Like sometimes copyright can be a real pain in the ass because now it's up to you to actually take legal action against people who are using it without rights. And then, so
No, but what happens is, look, again, on the internet, you can, whatever, let's say if there is an image, of course,
like the one I stole here.
yeah, but like you can copy it, you can right click on that and save it. But what is, because as James mentioned that this is a new space. So these are the new challenges which are going to come across. And now to cater for this scenario where Jing has mentioned, now Twitter is going to come up with its own feature where, of course, you can put your profile pic as your NFT, and then it will have a blue tick on it that, okay, this is a verified one. And but they can verify it on chain. Initially, they are going to support, I think, Ethereum NFTs. So any NFT, you can set it as your profile picture, and you will have a blue tick if it is a verified. So anybody who is just saving it as a JPEG, of course, his profile pic won't have the tick, and people will get to know that, okay, he's not the owner of this JPEG. That's, yeah, so the new kind of a utility, or people are going to come or try to solve whatever the challenges we have in this space.
Yeah, and I don't think it's like, blockchain and crypto is not, burn down the governments, kill the banks. It's, some people are obviously that way inclined, but, say, if NFT, if the government adopted blockchain technologies, then land ownership is more transparent. That'd still be potentially managing that blockchain and it would be somewhat closed. But what it is it's a sort of a public immutable source to say that here's the transaction of land ownership between parties and over time. So, people can get information on how land was transferred over time. They can get information of who owns it. And once again, if the government chose to just give out the public address, then it's anonymous because no one knows who actually owns that public address. They might have an internal database which says James Scurry is this address. Therefore he is the owner. But it's just more about how that technology can be used to provide, I guess, transparency in the future and pretty much the ability to perform real world transactions or contracts, in an open manner across the globe. I'll just get into DApps. We're close to the end now. So DApps are really decentralized apps. So, we talked about this blockchain technology. We talked about the consensus. We talked about nodes and all that. But a DApp is essentially basically how do you take all of this cool stuff and make it accessible to everybody out there? So DApps are really distributed applications. They're predominantly web browser compatible. So you just go to a website, you perform a transaction with a few clicks, then you connect your wallet and you pay for that transaction. So if I get a bit nerdy here, pretty straightforward though. Essentially, you've got the blockchain over here with all its cool bits and pieces and nodes and how it does its consensus mechanism. Then you have basically, where are we? So then you'd go write an application that talks to the blockchain, says, here's the smart contract address that I want to transact on. You create some cool web pages that say, do you want to enter into this arrangement, pay 100 Ethereum, and that will actually interact, that user's browser will directly interact with the blockchain, say, here's the contract that this person's asking you to enter in on. Please connect your wallet and provide authority to transfer your coins into the contract. And then they hit OK. Your smart wallet in your browser pops up. You can put in your magical passwords or whatever you've secured that with, complete the transaction, and then the browser would actually say, transaction complete. So essentially, without logging into a bank or anything like that, you've been able to use a browser web page, go to a website, use your wallet in your browser to actually pay somebody, and you didn't have to get permission from a bank or sign up for an account with anybody. Just wrapping things up here, you know, some of the real world things, I mean, sky's the limit. Whatever you can program, you can also start doing with blockchain, especially this Turing complete ones with oracles. So, you know, you can do financial loan, insurance, logistics, anti-fraud, you know, the list goes on. But, you know, these are real world uses today. You know, these things are actually happening today. Like, so you probably know the number more than me, but I believe, you know, in some of the financial loan systems, they're, you know, it's probably about $50 billion a day are changing hands in financial loans. Like, so it's not sort of kids in the street playing with this technology. It's real institutions, real tycoons that are actually giving out loans to people and also lending money. Last but not least, I know I haven't talked about trading and buying and selling and all that, and I'm happy to I'd probably bring Sohaib in because he knows a lot more about that than me. But if you are going to trade, if it's not your wallet, it's not your money. So what I'm saying there is if you signed up to say Coinbase or CoinSpot, which is one I use, that's an Australian exchange. When you buy and sell coins on those exchanges, that's their wallet. They're telling you that you have bought that many Bitcoin or that many Ethereum, but essentially if they got hacked, bad luck to you. You just lost all that money. So what I always say is put it, once you've purchased it, you can transfer it to your digital ledger wallet, which means then you own it. It doesn't really matter what happens to those exchanges or the internet. At the end of the day, you have those coins or those assets safely locked away in your control and no one can take that away. All right, there's more reading references here. Well, I've added, and I'll send this out, but essentially I have here, so some further learning that I've sort of come across over the time, and also some references. So as I mentioned, here's some crypto trading exchanges. This is CoinMarketCap's a good one to sort of see where everything's at and the volumes and market capitalization, how many things are in circulation. If I go backwards here, there's some good learning YouTube channels and some videos that you can watch to learn a bit more. And that's probably it. One thing I was just going to say, like, it's just about, you know, I'm sort of, when we look at gold versus Bitcoin, and I'm not saying Bitcoin is gold, but it is sort of widely said that Bitcoin is sort of the gold of crypto. A lot of people sort of say, well, what's the value in Bitcoin? You know, and then you say, well, what's the value in gold? And everyone goes, well, we all know the value in gold. And it's sort of like, well, do you really? I mean, like the value of gold right now is $1,800 US. It only costs $1,100 to mine. So, you know, basically, why is it valued at $1,800 if it only costs $1,100 to mine? You know, that's where value gets created even in gold. So we're looking at 1.64 ratio, saying basically 64% profit if I go and mine gold. Total supply annually is 8.6 billion ounces a year and grows 2% annually. The total supply, there isn't a total supply, it keeps getting mined. But when we look at, say, Bitcoin, its current value around, well, it's probably changed, 53,000. Cost to produce is around $19,400 in energy and electricity bills. The ratio value, yes, it's higher than gold, 2.7, but the total supply is fixed. There's only ever going to be 21 million coins produced. Currently available is 18.8 million. So it's a deflationary asset, essentially, which does have a mineable wealth, and produced annually going forward is about 1.2%, reduced every 4 years by 50%. So it's actually shrinking and shrinking how many coins get produced a year, roughly every 4 years, until it hits 21 million, and then that's it. There will be no more Bitcoins produced. Not going to say anything about that. I've just sort of wanted to just put up some information there to sort of compare some of the, I guess, the financial qualities of both. That's it from me, unless anyone has any questions. Thanks,
Thank
Jim.
you very much. I really enjoyed it. I'd like to have another session about tokenomics.
Yep. That sounds good. So what I might do is maybe Sahab and I, when I'll probably wait till we're back in the office because it took a little while to put this together, and I think it's worth putting in the energy so you can sort of get the right information out and not sort of be scrambled. But yeah, definitely, I'm happy to sort of co-host one if Sohad's willing to sort of. I know the only reason I say that because I know he knows a lot more than me around sort of the tokenomics. And when I say that, not just the investing, it's more about what tokens you use for what and why, which you heard a lot of then in that discussion.
Yeah, sure, James. I can be part of that one. Yes.
Cool, thanks.
Extend on this one. Yeah, you've already
I touched a bit on
you
the
touched
tokenomics.
on almost every aspect. So then we can expand on that one, especially in
Yeah.
terms of the dApps. That's where I believe that the most of the value is gonna be.
Yeah, and the tokenomics too,
Yeah.
Jingjing, is really interesting because you probably heard the term shitcoin, Shiba Inu, and Dogecoin. The reason they're called shitcoins is because the tokenomics just don't add up. And some of that could be around, you saw there, I said 21 million Bitcoins will ever be produced. A lot of these coins that get generated, they'll say basically we'll only ever produce 8 billion coins, which is a huge amount. And also the people who just generated those coins own 60% of them. So straight away you're looking at, you can see that tokenomics and you can say, well, there's no point in even investing or trusting these people when they have full control of the DAO, which is the voting rights. They own most of the coins and they'll probably dump them on the market one day and devalue the whole thing. So tokenomics is very important if you're looking at sort of getting involved in the investing in some of these companies or I guess institutions.
Yeah, I watched Coin Bureau. That guy is awesome.
Oh yeah, he's very good.
But I can't ask questions, so I prefer to talk to you guys.
Yeah.
Yeah.
All right, cool. Yeah, we could make it informal. I'll have a chat with Sahab, but maybe we could just have a bit of an info session and then also an informal sort of chit chat afterwards.
I think, James, as a practical exercise, everybody should transfer 1 Bitcoin to me so they understand how it works.
I was actually going to do that. I was thinking of saying the first person who can send me their wallet address, I'll transfer X. Just as sort of to get everyone involved.
James, we can send him on the testnet. That's fine.
Oh yeah. We'll send you $1 million Ethereum.
Yeah.
There was a unity everywhere.
On the testnet.
Yeah. Cool. Also, not that I'm a smart contract genius. I've only written 1 or 2 just to play with it. Might be worth having just to sort of write your own first smart contract session too. Cool. All right. Thanks everybody for coming along. I hope you learned something new and yeah. And
Thanks, James. Thanks.
that's
Thanks,
all right.
James.
Thank you.
Thank you.
Thank you,
I hope
James.
we can have
Thank you.
something
Thanks, guys.
guys.
Thank you.
Thanks, Jim.
Thank you.